The Water Cycle, written by Robert N. Knight. Introduction. Water covers 3/4 of Earth's surface. Other planets have only traces of water or no water at all. This is why Earth is called the water planet. As the number of people on Earth increases, more water is used. More people also mean more pollution. Earth's fresh water becomes more and more precious. In this book, you will learn about how Earth's water moves and changes. You will also learn how it is used and why it must be protected and conserved. The majority of Earth's water is found in the oceans that cover most of Earth's surface. Ocean water has many minerals. These minerals make ocean water taste salty. For this reason, ocean water is called salt water. The water that is not found in the oceans is called fresh water. Only 3% of Earth's water is fresh water. Fresh water is found in lakes, rivers, and streams. It is also found under the ground. Most of Earth's fresh water is ice. It is found around the North and South Poles in ice sheets and icebergs. It is also found in mountain glaciers. The movement of water. Everything on Earth is made of matter. The 3 states of matter are solid, liquid, and gas. Most water on Earth is liquid. Some of it is solid ice, and some is a gas we can't see. That gas is called water vapor. Earth's water moves in a cycle called the water cycle. As it moves from place to place, it changes from liquid to gas and gas to liquid. It also changes from liquid to solid and solid to liquid. Water needs energy to change from liquid to gas or from solid to liquid. The energy it needs comes from the sun. When water changes from liquid to water vapor, the process is called evaporation. This is the first step in the water cycle. Sunlight hits water on Earth's surface. Tiny particles that make up water, called water molecules, absorb some of the light energy and begin to move. As they get more energy from the sun, they move even faster. When they get enough energy, they escape the liquid water and enter the air as water vapor. When warm air near Earth's surface begins to rise, it cools. As the air cools, the water molecules in the air begin to slow down and lose energy. They collect on dust particles floating in the air. These molecules join other molecules and form tiny water droplets. As they lose energy, they change back to a liquid. This process is called condensation. That's the next step in the water cycle. As more and more water droplets gather on dust particles, clouds begin to form. As more droplets form, the clouds get thicker and thicker. The clouds can get so thick that they form thick, dark storm clouds. Wordwise. Different clouds have different names. The names of clouds come from Latin words. Here are some Latin words that are used to name clouds. Cirro equals high. Cirrus equals feathery. Cumulus equals fluffy. Alto equals mid-level. Stratus equals layers. Nimbus equals rain or snow. Cumulonimbus, large, fluffy rain clouds. Nimbostratus, thick layers of rain clouds. Altocumulus. Mid-level fluffy clouds. Cirrostratus. High layers of clouds. Cirrus. Feathery clouds. Precipitation. Clouds can bring rain, snow, sleet, or hail. Each of these is a type of precipitation. That's the next step in the water cycle. Rain forms when air inside a cloud gets cold and droplets get closer together. Little droplets join to make big droplets, and big droplets become raindrops. When they get too heavy to stay in the air, they fall to the ground as rain. When the air in a cloud freezes, water droplets turn into ice crystals. These ice crystals join together and fall to earth as snowflakes. Precipitation can change after leaving a cloud. Sometimes rain freezes after leaving a cloud. Then it becomes sleet. This happens if the temperature beneath the cloud is below freezing. At other times, snow melts on its way down to earth and becomes rain. This happens if the temperature of the air beneath the cloud is above freezing. If the temperature on the ground is freezing, rain will freeze after it falls from the clouds. Everything gets covered with ice. This is an ice storm. Water on the ground. Most precipitation reaches the ground. When it does, it often flows over the ground or soaks into the ground. Water flowing over the ground is surface water. Surface water flows from highland to lowland, eventually flowing to the ocean. Since it runs off the land, it is called runoff. The area of land from which water runs off into streams and rivers is known as a watershed. Water that soaks into the ground becomes groundwater. It travels through the tiny spaces between particles of rock, sand, and dirt. Underground areas where large amounts of groundwater collect are called aquifers. Groundwater is an important source of fresh water for many people. Water wells are drilled into the ground to get fresh water for drinking and other uses. If water is taken out faster than rain and snow can replace it, wells can dry up. Sometimes people dump harmful chemicals onto the ground. These chemicals can follow the same path as groundwater. The groundwater then becomes polluted. We must take steps to stop dumping harmful chemicals onto the ground. Once chemicals get into the groundwater, it is hard to get them out. This reduces Earth's supply of fresh water. Erosion. Sometimes surface water moves across land with great speed and force. This fast-moving surface water has the power to wear away rock and soil. This process is called erosion. Eroded rock and soil often end up in rivers and streams. Farmers and foresters worry about erosion. It can remove valuable topsoil from land. Plowing fields and cutting and burning down trees expose the soil. Heavy rain can carry the soil away and dump it into rivers and streams. The best protection against erosion is to keep plants growing in the ground. The roots of plants keep the soil tight. Planting crops across a hillside can help too. Replacing trees that have been cut down also helps keep soil in place. The Grand Canyon is a very deep and beautiful canyon. It was formed when fast-moving river water eroded soft layers of rock. Many of the world's canyons and valleys have formed in this same way. It took about 1 million years for the river to make the Grand Canyon. The river and runoff remove bits of rock and soil every day. Wowzer! The Grand Canyon is over 1.6 kilometers, 1 mile deep, and up to 30 kilometers, 18 miles wide. That's a lot of erosion. Deposition. The sand and soil, called sediment, are carried into streams and rivers by runoff. The river carries the sediment downstream. Wherever the moving water slows down, some of the sediment is deposited. This process is known as deposition. Deposition of river sediment causes two kinds of land formations. When rivers bend and turn, the water slows down on the inside of the curve. Sediments are deposited along the inside bank to form a sandbar. Rivers also slow down when they enter an ocean or large lake. Large deposits of sediment, called deltas, are found in these areas. Because deltas are made of rich topsoil, they make good farmland. Wowzer! The human body is about 60% water. There wouldn't be much of you left if the water evaporated. Controlling water. People need water. For years, they have settled in areas with plenty of water. Where there was not enough water, they built canals and ditches to bring water to them. They built dams and ponds to store water. Farmers have built many kinds of irrigation systems to bring water to their crops. They have even used irrigation to grow crops in desert areas. Modern dams that are hundreds of feet high have been built. They are used to prevent floods, to store water for use during drier times, and to make electricity. People have also put large pipes into the ground to carry water long distances. Water used in homes and factories is sent to sewage treatment plants. It is cleaned and then returned to the water cycle. Water uses. Most of Earth's fresh water is frozen in polar ice and mountain glaciers. Only about 1% is available for living things to use. Fresh water is important for many reasons. The United States uses 40% of its fresh water to water crops. Industries use water for cooling things down and for cleaning things. People use large amounts of fresh water for drinking and bathing. They use it for cooking, cleaning, and watering plants too. In some parts of the world, clean water is hard to get. As the world's population continues to grow, fresh water becomes even more valuable. Water conservation. Where will our future fresh water come from? Some people are digging deeper wells to find more water. Other people are building factories that change salt water into fresh water. Water from these sources is more expensive than most fresh water today. Scientists are discovering ways to conserve water. For example, they have invented toilets that use very little water. Some irrigation systems are now placed on timers. They deliver the right amount of water directly to each plant. People can learn that our supply of fresh water is limited. We can learn how to conserve water. Things people can do to save water. Turn off the water when you're not using it. Don't run the water when you brush your teeth. Take shorter showers. Fix leaking faucets. Wash dishes and clothes only when you have a full load. Collect rainwater for plants. Water the lawn in the evening. Put lawn sprinklers on timers. Put in drip systems. Conclusion. Without water, our planet would be a wasteland. Water and air are the most important resources for living things. Water changes the way Earth looks. It forms rivers, lakes, and oceans. It builds valleys and canyons. Water is constantly on the move. It changes states between liquid, gas, and solid. The water cycle brings us clouds and precipitation. Water is a very important resource. We need to keep it clean, and we must not waste it.